So the final type of calculation in the quantitative chemistry topic is the calculation called percentage yield. Thankfully, after the ordeal that limiting reactants are, it's actually not that tricky a calculation to finish with. It's normally stuck on at the end of a question, normally as a wee 2 marker, but it's a wee calculation to work out how successful a real life reaction is. What I mean by that is this. So let's say we've got this wee scenario. If I've got a reaction between magnesium and oxygen, so this would be the equation for it. And let's say hypothetically I've got a certain amount of magnesium, I've got 24 grams of it. By this point in the topic, I should be comfortable enough in working out with a mole calculation, maybe using the table method, from a certain amount of one of the reactants, how much of the products I should get, or in this case, one product. So I'm not going to work through the whole now, but you should be able to do that. If I do my wee calculation, at the end of the calculation, having worked this out in advance, I will end up with 40 grams of magnesium oxide. So here's the question where percentage yield comes into it. The word yield just means how much of something do you make. So I should be making 40 grams here. If I've got 24 grams of magnesium, according to my calculation, that should give me 40 grams of magnesium oxide. So I get my crucible out, fire up the Bunsen burner, and start heating it to react my magnesium with oxygen. At the end of that reaction, I actually weigh the magnesium oxide I make as a product of that reaction, and I only get 38 grams of it. Which makes it seem like there's a mistake somewhere. I should have got 40 grams, I only got 38. So you might think, well, is the mathematics wrong? It's actually not. It's nothing to do with that. I should have got 40 grams. This 24 grams should have turned exactly into 40 grams of magnesium oxide. It's actually to do with the practical aspects of chemistry. Very, very rarely will you actually get every last bit of what you expect in a reaction. In most cases, you'll end up getting a wee bit less. So in terms of wee bit terminology, we'll look at why you get less in a second. You've got two types of yield here. Remember, the word yield just means how much do you get in a reaction. The yield that you calculate in a mole calculation is known as the theoretical yield, which kind of makes sense. Because that's the one you calculate using your theory or your calculations. The yield you get in a real life experiment, which they might tell you about in the exam, is known as the actual yield, which again hopefully makes sense because it's the one you actually get in real life. So the actual yield is the one in the experiment. The theoretical yield is the one you get in your calculation. So we mentioned the fact that you never really get as much as you expect to get in real life. In terms of reasons for that, so we're going to flip forward a wee bit. We're going to go past calculation, come back to it. So that's page 9, page 10, got calculations. Actually go on to page 12, buried down there. You've got 3 bullet points, which are quite important. So in your exam again, a wee 1 mark question could be, give a reason why your yield is not 100%. In other words, you're not getting every last bit you're expecting. There's some potential reasons you can bring up. There's it here. First point is that some reactions do not go to completion. The reaction may be reversible. Maybe sounds a wee bit complex. Basically what that's saying is when you're doing a mole calculation, you're assuming that every last bit of the reactants will react. In reality, you can't guarantee that. Some, in that example I looked at, some of the magnesium might not have got into contact with any oxygen, therefore couldn't have reacted. So you can never quite guarantee that everything will react as you expect it. Second point is more like a practical chemist point. Some of the product may be lost when separated from the reaction mixture. So that could just be when I'm skipping out my product from my crucible into the base or the balance to weigh it. I might just lose some. Some might be lost on the spatula or in the crucible. So I can lose stuff just from practical techniques. And the final one, there may be unwanted side reactions among the reactants. So again, with the example I looked at there, I was making the assumption that this is the only reaction that can take place between magnesium and oxygen. Who knows, particular reactions, there could be other potential ways that reaction could go, which would mean that some of the reactants would be used up without actually getting magnesium oxide. So it could be side reactions that would reduce the amount you actually get in real life. But long story short, if you're able to learn those 3 bullet points off and plonk them down in the exam, if they require them, that's what you need to learn off there. So the last bit is, just as I mentioned, there's a reasonably simple calculation you have to be able to do to work out percentage yield. So we've a terminology again, so I've mentioned this already. you need to be really comfortable with your two types of yield. The actual yield is the amount of product that's actually there at the end of the process or the reaction, the one you get in the experiment. The theoretical yield is the one that you would have expected and nothing had got lost. In other words, the one that your mathematical calculation told you should have got.